chat. Every broken enemy now. Okay, there we go. Stair. Don't need postman. Oh, quit everything. Okay, we are live. Gonna get rid of this side quest. Fuck that. Actually, yeah. This for links. Useful links slash. Yeah, let's put that. Yeah, I can put this SSD. Put this here. Oops. 1306. Put that here. And oh yeah, Andrew's blog, definitely. This was quite helpful. Andrew blog. Okay. That's good. Good enough. I'd say yeah. Commit. Excuse me. ESP. Oh, okay. All right. Okay. If I am honest with myself, I am a bit stuck. Like, and I don't know how to proceed. Let me see. ESP 82s. Is it 66? Yes, I think it's on the board. Okay, let's look for that. ESP01S comes up. The challenge is, so far at least, what's the challenge? Thinking. Yeah, I need something like Andrew's blog to help me out, you know. Okay. What is this? Yeah. Mm, the question is, can I get away with not using the SDK? Or do I want to write the SDK myself? Don't know. Only if I could find out what needs to be done. What is the, yeah, what was the need for the SDK in the first place? And as I understand, the SDK is quite new. Maybe I search GitHub. P01. This ESP firmware from is that a binary? Yeah. No, what is it? It looks suspicious. Yeah, how does Arduino do it? Ah, there's two LEDs. I only see one. Got the pins. Got the two black stuff. Oh, got a crystal. Don't know why that gets picked up. Whenever I drop the cable down. Oh no. Okay. No, I was just looking at the crystal. Distracted. Oh, that's the memory. Cool. ESP8266. SOC. What is an SOC? I did find out what it was, but I forgot. Software something. No, it wasn't that. SOC. No. Okay. Should stop getting distracted. Where's the... Is that the antenna? Antenna trace. Does he say what that is? Okay. Mm-hmm. 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 Yeah. What is this install? ESP8266. It's me tapping on the mic arm. Me. Mm. Thing is, okay. ESP66. With and without Arduino. Okay. That looks useful. Maybe not that it matters. Hang on. How do I can't remember. I want to like update this. Never mind. A beginner's guide to... Oh, okay. Using the Arduino. Set up the software environment for development. ESP IDF, toolchain, project, build application. With and without an Arduino. Level 1, level 2. Yeah, okay. PCB design. Oh, okay. Not really. Does he talk about programming? He's built a few things. It's pretty cool. Okay, I don't want to get sidetracked later. Okay, I think I read all of this. Which board to choose? I already have a board. Too late. These are modules with EPS. Must be a typo, right? Yeah. For proper operation, including the antenna. So this on its own is enough. Interesting. Okay. SP 8266 sheet. I mean, it's quite the incomplete data sheet, this one. Technical reference. What's that? Isn't this the same thing? I mean, it looks pretty much like the other one. Yeah. Yeah. Oh, that was different. So maybe this is different. Software instruction. Huh. Is this it? I see the mention of SDK. Not happy. Mode user guide. I think this is different. Cause here, after okay, let me just save this. To 66. Says pretend data sheet. Okay. Okay, where does it begin? GPIO. The sniffer. I remember the sniffer. Fuck, my back. Back is killing me, man. You are. Let me just quickly read the I2C. There's one I2C used to connect with the microcontroller and other peripheral equipment such as sensors. Pin number 9 and 14. 9 is SCL, 14 is SDA. More on that later. Okay. I think this was missing. Hang on. Just close the rest. Yeah. I'll keep the SDK. Could be useful. Yeah, after 4, just jump there. Okay, damn, this is much bigger. Ooh. This is good. It's looking promising. Okay, let's go back. What is that? That is really cool. Don't know what device is called. I've seen, yeah. Nice. Looks good. Looks like something's happening. Okay. Okay, Yeah. No. Yesterday. Yeah. In the morning. Tried to do some reading and I hadn't had any coffee. It was rough, to say the least. I think in an hour I read about a page and I understood maybe or remembered 4 lines. I am addicted to coffee. Fine, I'll take coffee. Okay, back on point. Okay, we've got some pins. Okay, looks good. The quad mode flash. What does that mean? 6 I/O interfaces are used for flash. Excuse me. Jeez, what the fuck was that? 6 I/O interfaces are used for flash communication, and the dual mode flash 4 I/O interfaces are used. Doesn't seem important at this point. It's weird. Weird what the mic catches. Strange. GPIO function selection register. It's a bit of a mouthful. Mouthful. The SP MTDI is used to demonstrate the GPIO function selection. Okay. What is the MTDI? Oh, that's the name of the pin. MTDI. May find the appendix 1. Okay. Thank you. Right. Function selection register. That perifs IO mux MTDI U. This register differs for different GPIOs. Okay, I'm listening. Pin func select. Now, what the fuck is this function? Can't just like fucking randomly throw functions in the documentation. Okay. Yeah. What is MTDI? MTDI. Let's have a look at the first one. This is the first occurrence. Definitions of HSPI. Right. I don't know. MTDI. Is it like a common thing? The Republic of Korea. Don't think it's a common thing. Mike's doing like weird stuff. I'm gonna make it a bit quieter. How about now? Maybe. Find out. Pin func select. Yeah. Okay, I don't know what this is. Guess in constant. What's the value? Func GPIO12 equals 3. If you want to configure it to be function x, write x minus 1 into the bit in the register. For example, if you want to configure it to be function 3, write 2 into the bit register. What is 3? Yeah, this shit is a bit confusing. I am not gonna lie. If you want to configure it to function x. Oh. So you mean x being this? Oh. Okay, like literally. Function 3. So we write in function 4. My guess is okay. I mean, it's just a guess at this point. That's strange. What is all these noises? Am I like being attacked? Okay. Okay. I mean, for now, let me write some of this down. I was working on my project yesterday. Oh, project/product. Let's go. One user. What am I looking for? DNS. Okay. I think I created one for right ESP 266. So sick. Setting to oops. GPIO pins on the ESP. The ESP? Yeah, I just call it ESP. I'll take this example. Here, function number function is for GPIO equals func x example. Should be x minus 1. One. As of this point, I'm not sure what x or functions are. Wait further instructions. Hey. Moving on. Output registers. How big are the registers? 16? Not sure. Output enable register. GPIO enable W1TS. The output enable bit readable and writable. If the related bit is set to 1, the IO output is enabled. The related bit is set to 1. IO output is enabled. (15:0) contains 16 GPIO output enable bits. Output disable register. W1TC. The output disable bit put enable, disable, enable status. Output disable. Output registers output to what? If the related bit is set to 1, okay, think I did that. Output enable status register. Bit 5, that's my chair. Bit 15 to 0. The output enable status bit. Value of bit 15 to 0 of this register shows the related pin output enable status. Output enable status. Okay. And why 15 to 0? What does this actually mean? Time for AI. Not sure. What was I looking for? Yeah. What does this actually mean? Oh. It's used in hardware description languages. Okay, interesting. Indicates we're dealing with binary. Okay. Specifies the range of bits from bit position 15 down to 0. Is slightly confusing. Is it that way because of the network engine? Nah. Then it's too. Okay. I was right about that one. Maybe. Okay. What does this mean? Is this some hardware language too? What about this section? What are these functions? Each pin can serve multiple functions. Yeah. Oh fuck. Do I have to do this myself? Eesh. It's gonna be rough, man. Oh no, I could do the same that I did for. Okay. Up main, go there, go up. Oh fuck. Got to save it. Just put main down for now. If I go here, if you notice, SQC address, down. Where do I set the SDA? I don't. Maybe in main. Yeah, I do. Okay. Yeah, so guessing I can do this here. Then what do I do with this pin? Schmidt trigger, set function. Pin. What is a pin? Okay. What is MTDI? Oh yeah. What is MTDI? Okay. Now I know. Master test data in. That means coming from another device, right? You learn something new every day. Okay. I'm guessing I can do a lot of this with microsig. Shouldn't have to do it myself. Out GPIO input register. GPIO interrupt registers. What do you say? The mic is feeling weird today. Hearing all sorts of noises. Okay. Where was I? Input register, I got lost. I wonder. Well, it would be nice if Mikosko was around. Could ask him a few questions. Okay, let's keep reading. There's no point being stuck. Okay, we can reset it by writing data into there of GPIO enable W1TS and bit 15 blah blah of W1TC. Users can control bit 15 of GPIO enable. Okay, a bit too loud. Ah, fuck, is that it? Then it was my headphone. Too loud. Distracting. For example, when bit 0 of is set to 1, then bit 0 of that equals 1. When bit 1 of that is set to 1, bit 1 of GPIO enable is 0. What? It's just like willy-nilly. Just say whatever. By writing data into GPIO enable W1TS, and bit 15 of that Users can control bit that of GPIO enable. I got distracted. Okay, I'm back. I was daydreaming. Bit 15. Users can control of GPIO enable. For example, when bit 0 of GPIO enable W1T is set to 1, then bit 0 of GPIO enable equals 1 when bit 1 of GPIO. Jeez, why do I sound so weird today? No clue. Excuse me. Mic check. Maybe the mic's turned. I don't know what's up with today. Okay. Back to here. So if bits 0 set to 1, okay. If it's enabled, then the enable pin is 1. When bit 1, it's 0. Weird, but okay. I'll put a low level register GPIO out W1TC. Write only register. If the related bit is set to 1, the IO output is low level TV. At the same time, user should enable the output. Bit that contains 16 GPIO output statuses. My god, I am so fucking lost. It is mental. My chair is sinking. Okay. Output level register. High level that. Don't know if this is relevant. It doesn't seem like it. Input register. bit 15 to 0, the input status bit. If the related bit is set to 1, the IO status is high level. If the related bit is set to 0, the IO pin status is low level. Bit contains 16 GPIO input status bits. Okay. And I think there are only 16. Oh, is that why they use? Interesting. Interesting. That makes some sense. And regarding the function, maybe there was another table. Pin number, IO, function name, PWM0. Okay. Right. Okay. GPIO interrupt registers. Interrupt type. That's a weird word, isn't it? Interrupt. Interrupt type register GPIO pin 12. This register differs for different GPIOs. Of course it does. Pin 12. I'm not going to interrupt anything. It's fine. It's going to run forever. Okay. Interrupt clearing. Okay. It's good to know these are here. Come back to it later. GPIO related APIs. Different from other IO interfaces, GPIO 16 belongs to the RTC module instead of the general GPIO module. Oh, it can be used to wake up the chip during deep sleep. You're not sleeping. Don't need to wake it up. One less thing to do. I wonder if they're referring to the SDK here. It's got to be. It's not looking good. It's not looking good at all. Different from other IO interfaces, GPIO 16 belongs to the RTC module instead of the general GPIO module. Oh, okay. What does RTC mean again? Real time something, maybe? I don't know. RTC module. Really? Real time clock? Okay. Okay. Okay, so GPIO 16 not really available. This one here. Okay, that's fine. One less pin for me to worry about. Right, okay. It can be configured to input or output mode. You mean input from RTC? Maybe. Okay. Parameter configuration. 3 scenes are given as an example. Configure the MTDI output high level and enable the pull up. Okay. Configure MTDI input mode and get its level status. Configure the MTDI to falling edge triggers interrupt. Okay. Not a clue. Parameter configuration for scene 1, act 2. Configure the MTDI to GPIO mode. Right. Not going to be testing anything, so it's fine. Just want to know how to get going. Pin func select. Then, oh, okay. Going through scene 1, which is this one, to enable the pull up. This sentence writes 1 into bits 4 to 5 of perifs IO mux MTDIU register, where bits 4 to 5 of that are set to 1. The MTDI is configured. No, thought I heard something. It's configured to the GPIO mode. For details, refer to, okay. Oh, aren't we on that section already? I guess not. Configure the MTDI output high level. Hello, Kinku, or call me Kinku. Kinku, funny name. How you doing? I'm just stuck, Kinku. I don't know what I'm doing. Well, I know what I want to do, but I don't know how to do it. And this documentation is not helping. Da-da-da-da-da. Okay, just gonna skip over this for now. Doesn't look too useful. Because I can still do this. This sentence has two functions. I put one bit into that and enables the test data output. Blah blah blah. Okay. All right. Let's. Don't want to know scene 2. Scene 3. Interesting. It is declared in gpio.h. Yeah, I had a feeling. It was talking about the SDK. If I go components, no, tools, no. Oh, I could just search. Anything? Oh, here. ROM. Input get GPIO number. GPIO pad pull up terrain. No. I think if these pins are connected to the Pico, the Raspberry Pi, I should still be able to control them from there, I think. I don't know. It's all a bit of a mystery. Maybe I search for this. Yeah, in the SDK. Oh, there we go. This is good. Yeah. So what is GPIO interrupt? Falling edge. Okay. This is a bit wild, to say the least. Damn. Okay. Configure the MTDI to GPIO mode. Okay, yeah. I've seen this like 4 times now. Yeah, you mentioned this before. Okay. Configure to input. Disable all. To input, okay. Oh, blah. Interrupt function processing. Interrupt handler. Register read. Status address. Okay, and if I register read. Oh, no. Nothing. Absolutely nothing. Compatibility mode user guide. So what was this? Number 2. Hang on. It's a good question. Oh, it was just GPIO. Okay. SPI. I don't care about SPI. Can we skip to I square C? SPI. Ooh. I mean, you could have put a better picture. It's like totally out of focus. Yeah, okay. Hopefully they have one for I square C. Come on, let's go. 4, still 4. Geez, 4 is huge. What's this? More graphs. No, not in the mood. SPI overlap and display application guide. No. Keep going. What's number 6? That's still 5? Yeah. SPI pass through 1 interrupt mode. No. Let's go Wi-Fi pass through 2 interrupt mode. Also no. HSPI host multi-device API. No. Yes. Finally. So ESP now has interfaces for I2C master devices and allows control, reading, and writing over the I2C slave devices. I2C master devices. I need it to be okay. Let's keep going. So all GPIO pins can be configured with open drain mode, thus easily enabling GPIO interface for I2 data or clock. I keep hearing things like outside. Don't know what's going on there. Okay, our clock functionalities. Besides that, the chip has pull-up resistance inside, which can help save the pull-up resistance outside. Not sure what that pull-up resistance means. As an I2C master has its waveforms of the SDA simulated from SPIO 0, where SDA accesses behind the positive edge of SCL. SDA accesses behind the positive edge of SCL. The SCL high and low levels will maintain, and thus I2C clock pulse will be around 100 kilohertz. No idea what that means. Hardware initialization. Okay. Set pin functionality and set as GPIO. Select pin functionality. Okay. What's that start condition? Select pin functionality and set as GPIO. Set the GPIO into open drain mode. Initialize SDA and SCL as high levels. Disconnect GPIO and reset slave state. See. Okay. I2C master start. Let's check I2C. Okay. Oops. Did you? What is happening? Okay. Okay. There's a lot going on. I don't know what any of it means. Param config. Now I'm hoping I don't have to do any of it, because seems like it's just setting up the I2C, which, if I'm not wrong, fuck, it's a huge file. Should be done by microsig. I'm hoping. Stop master response acknowledge master response no acknowledge flat lines dead. Yeah, might have, I don't know, at this point I want to just use the SDK, but I'm gonna try a little bit more, see if I can figure something out. Check I2C slave response, but I don't want to connect a slave to it. Write data on I2C bus. Read data from I2C bus. At this point, even with the SDK, I'm not sure I'm gonna make it work. Yeah. It's completely hopeless at the moment. Completely. Okay. Don't even know what the fuck that is. Master GPIO init. Burst read. Read from where? To address? What is the address? Yeah, I think That's it? Fuck. I am screwed. Okay. I guess I'm using the SDK. I don't know. Chair is sinking. Okay, fuck. Okay. What are my options here? 'Cause to be honest, this technical reference is not very useful. I think because it mostly just talks about how to use the SDK. Sab me. Whoa, there's an image. What does it do? What is this? But I mean, I think it's mostly me. Can't really blame the dog. Oh well, I mean, I can a little bit, cause don't know what's happening here. What if somebody else has done this before? You know. ESP 8266 driver from scratch. Scratch TCH. Oh, hang on. The place I bought it from, they usually have a data sheet. ESP 8266. They have resources in here sometimes. Yeah. This one. 0. Oh, is it 1.5? One S. Okay, that looks like an S. Is uploaded with this. Supports more functions. For more info, check here. I was here. No, I wasn't. This is, I'm guessing, good. Okay, let me just read the rest. Okay. Humidity, temperature. Read more. Okay. Community forum. Do they have search? Yeah, no newbie crowd. SPI overlap. Not sure. Okay. This looks actually pretty useful. This is from the GitHub. Yeah, it is. Okay. Okay. These are the 80 command firmwares for compiled with ESP80 source code. Ooh. This is different. Have I been looking at the wrong place this whole time? I wouldn't be surprised. How to update the firmware. Wi-Fi shield. Okay. How the fuck do you program this? Come on. Come on. Okay. Alright. Hang on. Not to get too distracted. I'll come back to this one. These are AT. What is AT? Firmwares for the SB compiled from there. The firmwares have two different sizes. 1 MB flash size. I'm guessing this one, yeah. Doesn't support OTA update. Firmware is preloaded with this one. Oh, that's just the device. Wrong page. Okay, so this is the one that's already on the device. What is Nonos? Nonos AT. Funny. Funny name. Nonos. Nonos is the legacy firmware from yep. SDK and no longer okay. It's not recommended, so I'm guessing it's. When was the last time this was? Oh, 4 years ago. Images. It's not looking good so far. I mean, it should be fine. 4 years. Not a lot changes in 4 years. Yeah. Okay. SDK and it's still actively okay. Good. However, the supported AD commands are not solely recommended to use the new design. Fine. Okay. I can use the new design. User guide. What's this? Command set. Now we're talking. Okay. Binary list, compile and develop. Let's have a look at that one. How to set AT port pin, commands, create factory parameter, classic Bluetooth, Ethernet. Where are you going to connect to Ethernet? Maybe. OTA, OTA update. How to update IDF. How to understand ESP80 differences of each type of module. API reference. Okay. Let me just read the rest of it and then I'll come back. Because cats are in the middle of a fight. Firmware versus Espressiv's firmware. Okay, what's the difference? Change UART port for AT command to pin 15 and 13. However, most of the hardware available in the market is still using 1 and 3 as its UART port. This makes extra wiring necessary in order to make... Yeah, okay. Thus we've configured the firmware and compiled it on our own so that we can use backpin 1 and 3 as its UART port. The rest of the features are exactly the same. Okay. I don't need the UART port. It's fine. No debugging needed. How to update the firmware? How to? No, don't care about that. Okay. I think that's everything. So this is the actual firmware. It's almost. Here comes the sun. The sunrise. Oh yeah, definitely. Sun has risen. Before using the ESP80 solution, please read the disclaimer. Okay, precautions. I mean, what's the worst that can happen? It's fine. It's a tiny little thing. Famous last words. Serve as add-on modules, easily integrating into existing products to reduce. Offers AT commands. Okay. What is an AT command? Basic, Bluetooth, WebSocket, compile and no. Go back. Okay. Probably should read. AT commands. Select your target chip from the drop-down menu in the top left corner that enable users to interface with expressive products. Where's the AT commands? Oh, here. Can I choose? ESP32. What if I don't see the device? AT commands. What is AT? What are AT commands? Attention. AT commands are specific command language originally developed by this person or company in the early 1980s. AT stands for attention and signals the modem that a command is coming. Okay. Way to control modems, allowing computers to perform operations like dial-in, hanging up calls. Okay. Relevant in modern telecommunications. What about Wi-Fi? I don't see Wi-Fi. Wi-Fi? Wi-Fi. Wi-Fi. The AT solution provided by Expressive allows for rapid integration. Hasn't been rapid so far. It's only been 3 days. Yet to write one line of code. And built in a large number of AT commands. Easy integration with resource-constrained host platforms. Easy to integrate, easy to parse command response. Okay. I don't know what version I'm using. No idea. Documentation for the latest version. Get started. It's a good place to start. On what technology selection? How to connect hardware, how to download. What is the SPAT? Excuse me. make some funny faces when I stretch. Okay, I don't know. This is not easy. Well, I didn't expect it to be this vague. I guess it's mostly me. I have no idea what I'm doing, so I think it's fair. It's like the ultimate side quest. But I was thinking yesterday, maybe I could mix it up a little bit. Cause yeah, I've been writing, I don't know, maybe, what is it? Writing an interpreter in Zig. And yeah, I'm following, Thorsten Boll's book. Looking good, by the way. Done it before. I think I did it a few years ago when I was trying to learn Go. Yeah, and it was super useful and it was a lot of fun. And so now that I'm trying to get better at Zig, I'm thinking of writing, well, not thinking, I am writing an interpreter in Zig. There's also like a lot of side questing here too, because yesterday I was trying to figure out, like here, how to, what's the word? Yeah, like how do interfaces work in Zig. And yeah, and I would say, what's it called? Yeah, still don't understand totally, but yeah, I'm trying to figure it out. And also another thing I wanted to find out is, how do I edit this, like while in the stream? Do you know what I mean? Edit stream summary while streaming. Twitch. Create a dashboard, stream manager. Oh. Edit stream info. I don't see it. Edit anywhere? It is. Where is it? Somewhere on the page, but I can't see it. Oh, okay. Oh, here. Fuck. I'm an idiot. Ah, okay. Now I see. Yeah. So right, okay. Yeah. Okay, so I can possibly do both. Okay, that's good. Yeah. Okay, got it. So right, yeah. So I think tomorrow what I'm gonna do is a little bit of linter work too, because I'd like to do both. Yeah. I guess that's it. Guess for anybody watching, thank you for keeping me company. I mean, can't be fun to watch, honestly. I wouldn't watch it because it's fucking just me flapping around like a lost bird. I mean, I don't mind it because, you know, I'm the one flapping around. But yeah. Anywho, I don't know. Hope you enjoyed it. And I shall see you here again tomorrow. Most definitely. Alright, have a good one. See ya.